All right, I think it's time to start. Cool. Buenos dias, everybody. I'm Mark. I don't speak much Spanish, so mi cerveza, that's about all. Anyway, okay, so my name is Mark Schoennagel. I'm the lead evangelist for the Americas, and I focus on automotive for Unity. And what we're going to talk about today is using CAD for real-time development. How many of you know what I mean when I say CAD? Cool, all right, excellent. So CAD is computer-aided design. Everything that we do in Unity is polygons, right? When you're working with CAD, it's NURBS. If you don't know what NURBS are non-uniform rational B-splines. They are infinitely smooth curves. So if you think of a font, when you zoom in on a font, the font is always smooth. Didn't used to be that way, but now we can make a font at 800 point and that font is always smooth. That's the same way that CAD works. With polygons, you get facets. As you zoom in, you start to see edges and points. If you take a sphere, the more you zoom in on it, the more you're going to start to see vertices. If you were to try to design a car engine with polygons, it would immediately explode because it's just not smooth enough. You can't make a perfectly smooth piston with polygons. It's impossible. Even if you have a billion polygons, at some point you still have facets. So that is why automotive manufacturers, industrial manufacturers, they use programs like CATIA, SolidWorks, all of these modelers that use CAD models, NURBS models. So in order to visualize those types of models with Unity, we need to convert them to polygons. So recently we partnered with a company called Pixies to make that all possible. So before I get into this, I want to show you a quick little video of some of the really neat things that Unity is being used for industrial uses, for automotive, aerospace, things like that. So here's a quick little video. Hopefully it'll run in my window here. Nope, it's all stuttery. I don't know why, but for some reason that doesn't play in PowerPoint. So I'll just show it to you as an AVI. Where's it at? Here we go. So this is really quick, just some of the really exciting ways that CAD is being used. So visualization, making a model really pretty, designing a car, figuring out where to put a steering wheel, training how to make an assembly line faster, video walls where people can actually interact with on walls, configurators. I want to buy a new car. How am I going to buy it? What options does it have? What leather does it have? I can choose all that now with these configurators. How the suspension works on a Ford Raptor, autonomous driving. Unity is actually being used around the world to teach cars how to drive. It's amazing. Because we can simulate any type of camera view that you can imagine, right? It's just a camera shader. There we have thermal, or here we're using it machine learning for making intersections safer. This is showing LiDAR, and now we're back to visualization. So again, really quick, I'm going to talk about each one of those here in the PowerPoint. So let's go back to good old PowerPoint, and let's turn that off. Hang on. Let's get rid of this, and let's go here. Next one. Okay, so we started to notice a few years ago that companies like these were using Unity. Non-gaming companies, Boeing, Volkswagen, Audi, all these different companies. So we started to think, maybe we should have a dedicated team at Unity to service these types of customers. They're very, very different than gaming customers. So the things that they do, like this, they design cars. This is how cars are designed today with clay models, full-size clay models, very expensive. They actually paint these models. They paint them, they put clear coat on them, they put them in a wind tunnel to check the aerodynamics. All of this can be done now virtually. Doesn't mean that car companies are not using clay. They will always probably use clay, but more and more they're starting to work like this. So I visited Audi in Germany a few months ago after Unite Berlin, and I saw this exact environment. So there were a team of engineers, and they were actually designing the next generation of Audi vehicles like this. And this is what they see. So you see the people here, and then you see their avatars. And so they're actually all in VR. They're making design decisions of these really cool cars. This gentleman here, he's an engineer, interior engineer. He's designing the interior. He wants to make sure that that steering wheel feels right, that the seat feels right. I actually sat in that seat, and I was able to virtually grab the air conditioning ducts and see the particle stream the way the particles of air would hit my face. Is it high enough? Is it low enough? You can make a lot of design decisions all in VR. It's really, really amazing what they're doing. And this is what he sees. He's in the car. He feels like he's in the car. He's holding the real steering wheel. There's trackers on there, so it's all tracked. It's all perfectly to scale. It really feels right. It's amazing. Training. Volkswagen has decided to close my screen. Those clever, ooh, I'm magic. Anyway, if you look over on this side of the room, so at Volkswagen, when every 5, 6, 7 years, they completely build next generation cars. That costs about $1 billion to do that. Every time you see the all new Ford whatever, that's a lot of money, a lot of investment. They have to retool the entire assembly line. In virtual reality, they're able now to completely design the assembly line and walk workers through how to build a car before they ever build that assembly line. The assembly line in Germany that I visited at Volkswagen is 3 kilometers long, one assembly line. They have that all in VR. It's incredible what they're doing. And they're actually able to train their employees to build those cars before one nut or bolt is ever turned. It's amazing. Car configurators again. You go to Lincoln, I want to buy a new Lincoln Continental. They hand you an iPad, you dial in what colors you want, what wood grain, what leather you want, and you buy the car. It's really kind of changing the sales process as well. All of these things need Unity developers. That's what's really cool about this. All of you guys out there now who are designing games, go work at a car company. Really stable jobs. They're cutting edge stuff, cutting edge jobs as well. They're all finding out new and incredible ways to use Unity to do this kind of thing. Again, there's the Ford Raptor. They wanted to visualize the suspension. They brought the CAD data in, and there it is. Even dashboards. When we come out with a new version of Unity, Unity for Small Things is kind of what it's codenamed, we'll actually be able to have a dashboard designed and built with Unity. You turn on your car, you won't see powered by Unity, of course, but you'll turn the key on and a Unity executable will launch. It's going to be really fast. It's with Unity for Small Things, and we're just starting to design that now. And then, of course, my favorite is machine learning, teaching cars how to drive virtually. In Southern California, or in Northern California rather, in San Francisco, there are banks, tens of thousands of computers running simulations, teaching cars how to drive. They basically build a huge Grand Theft Auto, and they have cars driving. And instead of hitting people for fun, because we do that in GTA, right? You're doing that to avoid that, so to teach the cars to not do that. It's really incredible because we can simulate all these different cameras. If you look at a Tesla has 7 or 8 different types of cameras. It doesn't have LiDAR, but it has like a real virtual camera, but also has a camera that's similar to thermal, like we see here. Then there's 360 views, so where you peel the camera open. So these are all easily simulated in Unity. All that data goes into the real self-driving autonomous vehicle computers, but it's all a Unity simulation. The computer has no idea that it's looking at a Unity rendering. It thinks it's looking at the real world. And one of the neatest things that I learned about this technology is what happens when a bug hits that camera. What if a big grasshopper splats hits that camera? The car can't crash. It can't just pull over and stop. So through machine learning, it uses other cameras that it has to figure out how to compensate for that lost camera. Crazy stuff. And then LiDAR, simulating LiDAR. So this is a more photoreal version that Unity outputs. This is the LiDAR version, the laser version that these laser scanners create that are on these self-driving cars. So again, all this stuff is made possible because we now have this collaboration with Pixies. So we're able to bring this super high resolution CAD data into Unity and start to manipulate it. So I'm going to show you really quickly how that works. So I'm going to close this up and I'm going to launch Unity. So I have a brand new empty version of Unity. I have one prefab in here, which if I have time I'll show you, but I'm just going to go to my Pixies menu. I've already installed the Pixies plugin. I want to show you how easy it is and how fast it is to import some of this CAD data. So I'm going to click on import. Click on my little icon here, and I'm going to tell it to import the Lexus LC500H drivetrain. I don't want any LODs. I'm going to tell the quality to be at very high, the absolute highest quality, and I'm going to tell it to import it. Now this is going to take about 1 minute and 20 seconds. Normally, especially in a 20-minute demo, I wouldn't waste 1 minute and 20 seconds of your time showing you me loading something, but we're not loading, we're converting. We're converting the entire drivetrain of a real brand new 2019 Lexus LC500H from NURBS into polygons. What you're going to see is about 55 million triangles and 3,500 unique objects. So all being converted, not loaded. That's really important. So look, every single one of my cores, I have a 4 real core, 4 virtual core workstation or laptop. It's about a 2-year-old Razer, nothing fancy. And it's gonna do this in about 1 minute and 20 seconds. If I worked for Ford, if I worked for Boeing, I would have a really fast Intel or AMD Threadripper, some crazy machine with 16, 64, however many cores, and this would have been done in seconds. This blows people's mind who work in this industry. Normally they're used to their CAD models converting in days or sometimes many hours, never in minutes. So that's the really cool thing about Pixies is that it's wickedly fast and super duper accurate. So it's almost finished. I'm gonna go ahead and minimize my task manager really quick. And in just a second, we're gonna see this model appear. Now remember, what you're gonna see is 55 million triangles and 3,500 unique objects that make up this car, and we are done. 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 There we go. Sweet, there it is, check that out. Every single bolt, every single piece was just converted from high resolution NURBS data into polygon models. All the coloring comes from CATIA. This is nothing that Unity did. All of this was done in CATIA and then brought into Unity. If we take a look at the steering wheel or the steering column, let's just frame up on this. When we're game developers, we model this, right? We model just the things that people see. But when you're dealing with engineers, you have to create the airbag assembly. If we take a look at the Lexus logo, every single fastener that attaches the logo to the steering wheel has to be in the model. This isn't a design model, this is an engineering model. A very, very big difference between the two. If you're making Forza racing, you don't care what the pistons are doing unless you're gonna fly in there, but when you're doing engineering, you do. Look at this, that's geometry. Why would anyone do geometry with that in gaming? You wouldn't, right? But if you're engineering this, if this has to be created through a CNC machine or some type of a lathe or whatever's gonna make this, that has to be geometry. So all this crazy stuff, look at that, geometry, geometry. If I expand the prefab that it just created for me, I'm gonna show you all 3,000 of those objects. This is what just converted for you live, right? In 1 minute and 20 seconds. That's crazy. This blows people's minds at these facilities. I show this to Ford and they're freaking out. How is that possible? Look at that, it just keeps going and going and going. It's incredible. So this is all through our collaboration with Pixies. So we're really, really happy about that. And one of the neat things that this allows these car manufacturers to do is, they use programs like CATIA, again, SolidWorks. Those don't animate. Those don't have virtual reality. They can't do particle effects. They can't do explosions. So once you get this data into Unity, we can take all the power of the Unity game engine and throw some of these really cool gaming effects at it. One of the things that's super popular in this environment or this type of work is the exploded view. Not like when we think of exploding something, by launching a missile at it, but the exploded view where you can see all of the parts inside of it, right? Well, we can just write a simple script for this. You can't do that in these other modelers, right? So watch this. I've got a quick little script that's going to allow me to do the exploded view on this model. Now, one thing that's weird about CAD models, they put the pivot points in the weirdest places. So, you'd have a tire and normally you'd want it at the center so it rotates there. No, it'll be like way over there. And pivots are just always in a very random place, it seems. It's not random, but it doesn't make a lot of sense for a game developer. So for me to get this script to execute correctly, I need to tell all the pivot points of all 3,000 objects to be located at the dead center of the world. So I got a quick little script to do that. You don't see anything happen, it's all automatic. I just click on Custom Tools, Adjust Hierarchy, and that resets my pivots. So all 3,500 objects, or approximately, they're all now in the dead center of the world. I'm gonna take one other script. It's on here, it's called Move and Examine. I'm just gonna drag and drop that on here. And Mike Geig, who spoke earlier, he wrote this awesome script for me. It's really not a whole lot of code, but what it does is it basically builds a bounding box for the size of my model. So this will work on everything from a 777 jet down to a little tiny assembly. So it figures out how big this CAD model is, makes a bounding box, and puts the expansion point right at the dead center of that as well. So from here, if I press play, and now I'm in game mode, play mode, if I use my middle mouse button, I can now do the exploded view, right? This freaks people out. Like you guys said, ooh, wow, but you're used to this kind of stuff, right? You're game developers. Keep people that model engines, they're not used to this. This freaks them out, like holy shit, Holy shoot, I can do that. Don't mind me. Look, it even says like Toyota on there. See that? Like the little Toyota emblem on there. But if we get, there it is, Toyota. All geometry. We can just fly in there, fly around. Look, inside the transmission, why would you put the bolts there? You have to put the bolts there with this. So really, really cool that we can do this. Again, this mind-boggling stuff. So I'd love to show you more. I'd love to show you this in VR, but I only have 20 minutes today, so we're not gonna do a whole lot. Sometimes I animate this with timeline, or I'll start throwing materials on it. But rather than throw materials on this object, on this model, I'm gonna get rid of this. And you know what? Sometimes this takes about 30 seconds to exit, so I'm gonna do this just to save some time. Just to save some time. And let's just launch another one. I thought my talk was 40 minutes, so I'm really condensing it. So we're gonna show you one other cool thing, the material library. So let's do this one first. So because we started supporting this automotive team, we thought, you know what, it'd be really great if we had a library of materials to show off automotive type objects. So if you guys were walking in, I was flying around that Volkswagen, all those really nice materials that were on there, those were all created with the workflow that I'm gonna show you here in just a second. So what we've done is we've created a library. It's about 150 unique objects or unique materials that just pertain to automotive or industrial uses. So leathers, wood grains, a lot of neat plastics, a custom car paint shader. It takes a second to load up because there's about 150 materials, different materials, all with different texture maps. And we actually have a process of making those, which we're gonna release to you very, very soon. So if I back out here, where am I in this scene? Oh, what, whoa, I'm upside down. Wow, all right. Come on, Mark, get this straight. All right, so this is the exterior of that Lexus. And if we fly a little bit closer, why is this not, stalled, hold on. Come on, there we go. All right, so let's just zoom in on this. So if we zoom out a little bit, first we see, look at that beautiful glass. So we're kind of checking out there. This is all HDRP, of course, really, really cool. Let's just frame up on this Lexus logo. There's all those fasteners underneath. Look at the nice shininess on there. Oh, very pretty. If we go there, look at that crazy material that's on there. We're gonna give you all of these materials. In about a month, month and a half, you'll find them all on the asset store, all for free. Yeah, great stuff, right? That cool metal on there. You know what's crazy? Those crazy automotive people, they even make the stitching geometry. They have to because it's a real object. They can't fake anything with textures. Crazy. Let's do this real quick. Let's just grab the chair, or the chair. Who has a chair in their car? A seat. So there's our seat, again, with some nice, very beautiful looking leather on that, right? But let's just say you wanted it to make it look like, I don't know, your grandma's couch. So there's grandma's couch, or there's some burlap, whatever. I'm sure Lexus is loving this. The most itchy car seat in the world. And of course you can change the UV on it, change the tiling of it to make it look better, or worse, whatever. And I could show you a whole bunch more of these. I wanna show you one other quick scene, and then I gotta go. I got 2 minutes left. So one more thing, launch it up. That's my Volkswagen, I love it, it's my baby. There we go, so here's a look at just the library of materials. Come on, load. How many of you know how car paint works? Okay, good. Car paint actually has 2 layers. You have the base coat, and then there's a clear coat on top of it. The clear coat changes the index of refraction and also the way reflections work, which is why car paint has almost like a more beautiful look, like you can kind of reach in there and grab it. It's that clear coat that does that, and the Unity car paint shader will have all that in there, as well as the ability to have pearl and metallic flake, which is also super popular with car paint. But this is a portion of the material library. This isn't even the whole thing. But these are all the different materials that we are going to provide for you. And as you get close to them is where you really start to see the detail. So I'll just zoom in on a few of these. Like so, like there's that, The scale is a bit off on this one, so it's a little hard to navigate. I have to make a little better version of this one of these days. Yeah, so you can see there's kind of like that leather that we saw earlier. This is a very German style headliner right there. All of these different materials for automotive, for industrial purposes. Here we have different types of metals. So like a really rough kind of a metal, somewhat brushed, very smooth. This one here works really well for like a brake rotor where you have a lot of scratches in there. And again, super high res. And if we show you one more on here, let's just grab this red, beautiful car paint. So there's the car paint shader, much different index of refraction on there. And again, we can zoom in, see all the nice, beautiful flake and paint on there. And this is just a shader we're gonna provide for you 100% for free. And then lastly, depending on how much you spent for your car, you're either gonna have real wood or fake plastic wood. And so we've got all that covered as well. So all these nice different wood grains and things like that for your dashboard to make all that look cool. And this is all coming for free, so that's all good stuff. I can't even believe it, I'm out of time. So that's it. Hope you enjoyed all this. I'll be around if you have any questions. Unity for Automotive, a lot of great jobs out there. So, you know, if you're using Unity and you want to find something a little different than games, a lot of great stuff out there for other uses. So that's only going to get more and more and more. It's amazing how many of these companies are using Unity today. So anyway, thank you very much. If you want any of the scripts that I have, I'll be more than happy to send them to you. I can send them to you if you go on to Twitter and just send me a little tweet. And my Twitter, oh, I should activate that one day. No one saw that. At Unity 3D Mark S is my Twitter. And I'll be happy to send you those explode scripts. And there you go. So thank you all very much. I will catch you around hopefully later. So thanks for coming out today.